This is an overview of the CleanStream's treatment system for cooling towers. This is a CS 800 on an 800-ton cooling tower. It consists of two sections. There's the water side and the gas side. On the water side, we pull water out of the cooling tower, circulate it through our sample rack, monitoring it, venturing the gas into the water, and sending it back into the cooling tower as treated. The proper velocity, if we get proper gas mixing, get 95% mass transfer balance. The other side is the gas side. Okay? We start off with air. We strip all the nitrogen out of the air, so we have 90 to 95% oxygen going into the ozone generator, which is the blue. The ozone generator basically consists of a plasma block generator where we have plates where we're passing the gas through and we're controlling the electricity between the plates. As the system's calling for more ozone, we run more electricity through the plates, generating more ozone. As we need less ozone, then we reduce the amount of ozone being made. This is all controlled by the controller here, which is directed by the ORP probe. So in times of high load, as you can see, we're dropping below set point right now and starting to kick in. During times of high load, we generate enough ozone to kill all the bacteria and destroy all the organics, while during low load periods, we're minimizing the amount of ozone generated to protect the system from corrosion. That is the gas side. The gas comes in here into the venturi. The main pieces that we have now are the circulation pump, where we're pulling water out of one side of the cooling tower sump, sending it through our sample loop, venturing the gas in under vacuum, sending it back out to the other side of the cooling tower. We have the sample loop here where we have the venturi. That is creating a pressure differential with a vacuum to pull the gas into the water. Then we have proper velocity for mixing the gas in the water to try to get approximately 95% mass transfer balance. This is the sample loop where we have the flow switch in case we lose the pump. It shuts the entire system down, so that's a safety feature where no ozone will be produced. We have the conductivity probe. That's reading the solids in the water to make sure we're maintaining proper cycles of concentration. As the solids in the water gets too high, it turns on the bleed valve down here, discharging concentrated water so that fresh water is made up and we dilute the system down. And then we have the ORP probe, which is controlling how much ozone we're feeding into the system. Sends a signal over to the controller. The controller tells the generator how much ozone to produce. Over here, we start off with the oxygen generator. This pulls straight air out, strips all the nitrogen out. We have 90 to 95% oxygen feeding into the ozone generator here. Okay, ozone generator is controlled by the ORP controller. We send the gas through the plates, creating ozone. The ozone gas comes out of that stainless steel line right there. And then comes over to here, where it's brought into the system under vacuum. This is the ORP controller here. As you can see, it receives a signal from the ORP probe. When it drops below the set point, it sends a signal to the generator to tell it to ramp up, produce more ozone so that we can protect the system, keep it clean. When it gets above the set point, it ramps the generator down so that we're not overproducing ozone. Strict control of how much ozone we put in the system is very important to protect the system, to make sure it's clean, and to protect it from overfeed. And then of course we have the bleed control system over here. Receives a signal from the conductivity probe and tells the system when to bleed to keep cycles and concentration in line. That is a quick overview of the CleanStream's ozone system. How we can protect cooling towers, conserve water and energy on chillers. Thank you.